Alright guys, this is 9.2 part 2, going over 30, 60, 90 triangles. This is another set of perfect triangles. So let's say I had an equilateral, equal angular triangle. So we kind of noted that, or last semester, that all the sides are the same, so the angles have to be the same, and we have to note that if it's equilateral, then it's also equal angular. So all the angles of a triangle have to add up to, you guessed it, 180 degrees. Okay? But if I have 3 of them, they have to be the same. How much are each one? So I would take 180 and divide by 3, so each one is 60 degrees. But now, what if I wanted to draw an altitude down the middle? And so what happens to my 2 at the top? It isn't 60 degrees anymore. It is now 30 degrees and 30 degrees. It's split in 2. So now I have 30, 60, 90 because I created a right angle at the bottom. So my altitude bisect, remember we talked about that, cut in half to form 30 degrees and 90 degrees. So I formed, by bisecting my equilateral triangle, I created 30 degrees and I created 90 degrees. Okay, so anytime you're solving for a missing length in a 30, 60, 90 triangle, you're going to label it like this. So in this case, anything closer to the 60 is going to be x. So we're going to talk about adjacent. So anything adjacent to 60. So if I say the word adjacent, that means next to. So anything adjacent to the 60 is going to be x. And then anything adjacent to the 30, in this case, is going to be x square root of 3. And again, this is still derived from the Pythagorean theorem. And then, for our last one, for our hypotenuse, it will always stay, as soon as my computer unfreezes, Alrighty, so anytime I have anything adjacent to 60, I'll have x. Anything adjacent to the 30, I'll have x square root 3, and that leaves my hypotenuse as 2x. Okay, we have those 3. So this one's a little bit trickier than 45, 45, 90 because you're dealing with 2 different sets of angles now. And so, I'm going through these examples with you. So, I have my hypotenuse, which is always across from 90 degrees. Do not forget that, always across from a 90 degree angle. This is our 2x. And then, what's closer to the 60? Well, that would be small x. And that makes that one 30. And so I have x square root 3 on this side. So label first. So label your triangle. Label your triangle first. And then, okay, so always label your triangle first. So I'm left with 2x. Little x is by the 60, and then x square root 3, assuming that this is 30 degrees in my corner. Okay, so now I need to solve for LM and MN. Well, I know that 14 equals 2x, and I can solve for x, my little part. So I'm going to solve for x by dividing by 2, and so x equals 7. So MN is 7. And now I need to just multiply it by x root 3. 7 times square root of 3 is just 7 square root of 3. And so that's how I label that triangle. Now let's try the other side. Try another example. On page 17. Previous page is page 16. We're on page 17 now. So now we're going to label our triangle. And so the little corner is 30 degrees. And what's closer to 30 degrees? Well, that's x square root of 3. Our hypotenuse is 2x. And then our little one next to 60 is just x. So I have 2 square root of 5 is x. So I can solve for my hypotenuse, or ln, by multiplying by 2. So I have 2x is really equal to 2 times 2 square root of 5, because 2 square root of 5 is x. And so I'm left with 2 times 2, which is 4, and I'm left with square root of 5. Then, if I'm solving for x, now I have to solve for ml. So if I'm putting x, if x is square root of 5, or 2 square root of 5, then I multiply it by square root of 3. And I'm left with 2, and then square root of 5 times square root of 3 is square root of 15. So ml, or ln, is 2 square root of 15, and ln is 4 square root of 5. Okay, so label your triangle first, and then solve for x. Okay, so let's try example number 3. So what am I going to do? I'm going to label my triangle first. So my hypotenuse is easy. I know it's 2x. And then anything by little 60 is going to be x. Note how this changed. And then the corner, as soon as it's 30 degrees, right next to 30 degrees, is x square root of 3. And so now I need to solve for 2x and x. Well, I have x square root of 3 is 8, and I need to solve for x. So x square root of 3 is equal to 8, and I'm going to divide square root of 3 in order to solve for x. So now this looks very similar to the 45, 45, 90 when we had a denominator, a radical in the denominator. However, we can't have that. So I have to multiply in order to get rid of it. So square root of 3 is square root of 3 is square root of 9. And then I have 8 square root of 3. However, square root of 9 is 3. So I'm left with 8 square root of 3 all over 3. And I cannot reduce, so I'm left with x square root of 3 equals 3, which was what x was. So x, or mn, is 8 square root of 3 all over 3. And now I can take my x value and multiply it by 2x. So now I have 2 times x, which we solved for, times 8 square root of 3 all over 3. So multiplying across, I have 8 times 2, which is 16, and then still square root of 3 all over 3. Okay, so that is your hypotenuse. So 16 square root of 3 all over 3. Alrighty, so now we get on to number 4. And number 4 looks really weird because it is not set different, or it's not set normally like how we would see it. So note that your hypotenuse is always across from your 90-degree angle. So this is 2x. Note our hypotenuse is always 2x, and adjacent or next to the 60 is little, or just x only. And assuming that this one's 30 degrees, I have x square root of 3. And so I need to solve for x in this case. So I have 4 square root of 3 equal to 2x. And I need to solve for x. So I'm going to divide by 2. So 4 divided by 2, though, gives me 2. So 2 square root of 3 equals x. And so I know that is this side is mn, so 2 square root of 3. And now I can take my x value and multiply it here. So you're taking 2 square root of 3 and multiplying it by square root of 3. So I'm still left with 2 because I have an imaginary 1 here. And then 3 square root of 3 is square root of 9. But square root of 9 is 3. So 2 times 3 is 6. So NL, or in this case, this part is 6. Alright, so that is page 17. So your practice pages in this case are pages 18, 19, and 20. 18, 19, and 20 are your practice pages. And so it's not necessarily hard as long as you know how to label, multiply, and divide radicals. And so, note, cross mirror hypotenuse is 2x. What's next to 30 is x square root of 3, and next to 60 will always be x. And so, like for our first example, we have pt is 4, and we know it's next to the 60, so it equals x. Next to 30 is x square root 3, and our hypotenuse is 2x. So we already have x given to us, and so we need to just plug in where x is. So this is really 4 square root of 3, and then I have 2 times 4, which gives me 8 on this side. So VP, or PV, is 8, and VT is 4 square root of 3. Okay, so your examples are very much like this. Make sure you, step 1, label your triangle. So label where they are. So x, x squared root of 3, and 2x, make sure you label it, especially if you're going across and what's next to the 60 and 30. And then your second one is solve for x, okay, and then plug back in. So plug x back in, okay? And so that is 9.2 notes, part 2 over 30, 60, 90 triangles. Thank you. Remember, your homework pages are from 18 to 20.